Hello everyone, and thank you for joining our webinar today. We'll just give the attendees a few more minutes to connect. Today we'll be talking about EQA for ISCN, the International System for Human Cytogenomic Nomenclature. So this is one of our series of webinars. We have previously done webinars on ISCN, which you'll be able to view on our YouTube channel. And this webinar will also be recorded and will be available for viewing in the future if you miss any of it, or if you'd like to watch it again or recommend it to any of your colleagues. Everybody will be muted while we are going through the webinar, but if you have any questions, please type them into the questions box as we go along, and at the end we will have a live question and answer session. So today we'll be looking at the ISCN pilot EQA, which was first offered by GenQA in 2021. So we'll give an overview of that EQA. Full information is available in the EQA summary report provided to the participants. We'll be looking at the fundamental ISCN principles which were assessed in the EQA and the results from the participants. As we go along, there will be examples which highlight the updates in ISCN 2020, and these will be coloured in green just to highlight anything that's new for you. You should have received some quiz questions in your registration email, so we'll be going through that as a quiz and we'll explain the answers. And then, as I mentioned before, we'll have a live question and answer session at the end. So I'd just like to introduce Ros Hastings, who is a key member of the ISCN committee.
Hello everybody. Just to give you a bit of background about the ISCN Standing Committee, there are 8 members from different parts of the world, from the Americas, from Oceania, from Asia, and from Europe. I'm currently the chair, and Sarah Moore from Australia is the deputy chair, so she helps out. We also have Johan Dunnan on the committee, and he helps us with the HGVS, where we have a combined ISCN HGVS nomenclature for next generation sequencing for structural aberrations. As you well know, the latest version of ISCN was published in 2020. This was a major revision, and this EQA is covering some of the changes that were made in 2020. If you haven't got it yet, there is an online version available, and that is updated a lot more regularly, although any changes that are made to ISCN 2020 are published in the Cytogenetics Research Journal. If you've ordered the hard copy, you can access this online version for 12 months. The great thing about the online version is there's a forum, so if you have questions, you can get a response from the ISCN committee to any ISCN problems you have. And as you probably are aware, GenQA is expecting the use of ISCN now in all of the relevant EQAs. So I'm going to hand back to Melody, who's going to talk a bit more about the ISCN pilot that we ran this year.
Thank you, Ros. So ISCN, as we all know, is very important. It's a key aspect of a cytogenomic result. And although obviously there is an associated text description, it is very important to get the ISCN nomenclature correct to avoid any confusion of what the actual result is, to be able to communicate that result easily to other scientists. And also it helps if there is consistent ISCN to set up and use databases effectively. So GenQA have seen a number of errors in our standard EQAs across the years, and also ISCN is difficult to keep up with. The cytogenomic techniques evolve, the nomenclature has to evolve with it, and the ISCN is obviously updated frequently to reflect that, and it can be difficult to keep on top of the updates. So GenQA decided to offer an EQA for purely just based on the ISCN in 2021. So this was run as a pilot, and participants were provided with ideograms and or images plus the written descriptions of the abnormalities online. So there would have been a schematic of a karyotype or a schematic fish diagram or a table of microarray results. You did not need to do any analysis. The result was given for you, and all you had to do was put down the correct ISCN nomenclature on the website directly. There was the ISCN was divided into 6 separate areas, which we're calling cases, and each case consisted of 4 questions. So GenQA recognises that there's variability in laboratory scope. For example, some laboratories might only analyse acquired results. And so it was easy to opt in or out of a case depending on your laboratory scope. And there wasn't any penalty if you opted out of any particular cases. However, we did request that if you were participating in a case that you answered all 4 questions within that case. And the participants were given 5 weeks to submit their ISCN results online. So for this first round of the EQA in 2021, we had 68 centres participating from across the world. There were 31 unique countries involved. And as you can see, the participation varied depending on the area of ISCN that was being assessed, with the most popular being constitutional karyotyping and the region-specific assays having a lower participation. But overall, more than 20% of centres participated in all the 6 cases provided for the EQA. So in this next section of the webinar, we're going to run through the fundamental ISCN principles which were assessed in each section of the ISCN and look at some of the EQA results. I'm not going to describe every question and answer in detail because all of that information is available in the EQA summary report, but we're going to highlight the updates in the ISCN 2020 and look at some of the common errors. So starting with constitutional karyotyping, as I said, there were 4 questions in each case. So the first question was looking at the use of inheritance terms, which is optional, but obviously if it's given, it should be comprehensive and correct. Second question was looking at an isochromosome. So the question told participants that the abnormality was an isochromosome. But for isochromosomes, you could choose to use the description of derivative and sometimes a Robertsonian could be appropriate. The third question was a mosaic result involving a 45X cell line and a cell line with a double ring. So double rings are formed through mitotic errors or sister chromatid exchanges during cell division, and as such they're unstable and unlikely to be passed to viable daughter cells. Describing a double ring in ISCN is quite difficult, and fortunately you can choose not to include it in this scenario because the double ring is an artifact of the cell division. We did see that several participants did describe the double ring, and if they described it correctly, then they were marked correctly. Question 4 was demonstrating that a polymorphic variant should not be included in the ISCN. It's strongly recommended to just reserve the description of these into the text only to avoid confusion and avoid looking like the ISCN is abnormal. And a common theme throughout the EQA was that cell numbers should only be given in constitutional results if that result is mosaic. And also looking at the order of cell lines. So a largest abnormal cell line should normally be listed first and normal cells would be listed last. And as you see on this slide, I've put in some page numbers of the ISCN 2020 for reference, and those ones in green are highlighting the updates in 2020 ISCN. So briefly looking at the results for this case, we saw that 16% of participants answered all the 4 questions correctly. A common error in question 1, which we'll look at in more detail in a second, was that some participants incorrectly used MAT when it should be DMAT. And in question 3, this was the mosaic result, and although all participants placed their cell lines in the correct order, 30% of them incorrectly described the double dicentric ring in the ISCN. In question 4, with the polymorphic variant, it was clear that a lot of participants weren't aware of the recommendation not to include that in the ISCN. So it was 62% actually did include the polymorphic variant. And as I said before, a recurring error is that cell numbers should not be included in non-mosaic constitutional ISCN. So looking in a bit more detail at question 1, this ideogram is an example of what was given to participants on the website with the associated text description here. So in this scenario, there's an additional abnormal chromosome, which is derived from part of chromosome 22 and part of chromosome 11. And participants were told that this abnormal chromosome was due to the unbalanced segregation of a translocation carried by the patient's mother. So the correct ISCN nomenclature for question 1 is shown here. So as I said before, some participants incorrectly used MAT instead of the DMAT designation. So if only part of an aberration has been inherited, the abbreviation, the appropriate one, either DMAT, DPAT, or DINH for inherited, is used to distinguish it from the complement in the parent. So this is a new thing for ISCN 2020, and it makes it clear that it's unbalanced in this patient. And then, although it wasn't assessed in this EQA, another important update in the constitutional karyotyping section is that breakpoints should now be specified from P-ter to Q-ter and not centromere to telomere as previous. So moving on to the second case, which was covering constitutional fish. Question 1 included that metaphase fish results should not include the normal control probes. So this rule has been around for a while, but it was clarified in ISCN 2020 to make that clearer. Question 2 showed that the abnormal results should be listed in numerical chromosome order and within probe sets. We'll look at question 4 in a bit more detail in a minute, but again, an update in ISCN 2020 is clarification that for determining the sex chromosome complement of an individual, it is appropriate to include the status of SRY in all cell lines that were present. We saw some errors with the correct placing and description of the signal pattern. For example, whether the ×2 should be put inside the bracket and using plus or minus for abnormal metaphase results only. So plus and minus should not be used for an interphase fish result. Again, there was a recurring issue with including cell numbers, and these should only be given if the result is mosaic. And throughout the EQA, but particularly in the fish cases and the microarray cases, we saw errors with punctuation. So just to point out here that the marking for this EQA was a little bit more strict than we would normally do in our standard GenQA EQAs. So we would class a punctuation error usually as a non-significant ISCN error in another EQA, and it would not have a deduction. But because the whole focus of this EQA was just on the ISCN, we did apply a 0.25 point deduction for a punctuation error. And if there were a lot of punctuation errors in an answer, then we might have pushed it up to a 0.5 deduction. And then the other questions carried a 0.5 deduction if they were incorrect. If the ISCN was given incorrectly, if it could be confusing, if it was incomplete. So looking at the EQA results for constitutional fish, there were 7% of participants who answered all 4 questions correctly. We were a bit surprised by questions 1 and question 3. So throughout the EQA, there were some questions which we thought would be more challenging than others. But question 1 was a straightforward normal Williams syndrome result. And we did see a lot of errors in this question. So for example, putting the ×2 outside of the brackets. So 56% of participants correctly answered this question. And similarly for question 3, a normal male rapid prenatal result, which was disomic for chromosome 18. So again, just a standard normal fish result. There were errors with putting the ×1, ×2 outside of the brackets or including extra brackets which were not needed. Questions 2 and 4 were more complicated and more errors were made. So we'll look at those in a minute. And again, the cell numbers should not be given for non-mosaic constitutional ISCN. So this is what was provided for question 4, the ideogram, schematic interface fish results, and a mosaic karyotype where 10 cells showed monosomy for the X chromosome and the remaining 10 cells showed an isodicentric Y chromosome. So to get the ISCN for this result, you first need to think about the G-banded results because they come in a group before the fish results. So thinking about the 2 cell lines, we have a monosomy X cell line in 10 cells and the isodicentric Y cell line in 10 cells. So usually the largest cell line would be listed first with normal cells at the end. We don't have any normal cells in this case, and the cell lines are of equal number. So we then go to apply the result that the numerical abnormality cell line should be listed first. So it should be the 45X cell line first. Then the fish results follow the G-banded results. So it's interface fish. We're looking at sex determination in this case. So the SRY results should be included for both cell lines. And we state the number of cells in square brackets after each fish result, after each cell line. And we include the numerator and the denominator for the constitutional fish. So we saw multiple errors within this question, splitting up the cell lines incorrectly, putting the fish results mixed in with the G-banding results, not including the denominator. So this question was more challenging. So looking at Neoplasia karyotyping, so there were some straightforward rules that have been around in multiple editions of the ISCN, which should have been followed for all of the questions in this case. So abnormal results should be listed in numerical chromosome order. Structural abnormalities should be listed in numerical chromosome order, followed by the alphabetical order of the aberration. And as a difference to constitutional ISCN, cell numbers should be given for all acquired karyotypes, including when all the cells are normal. So we'll focus on a few of these questions in detail. So question 1 was looking at the use of the designation query C for the origin of an additional X chromosome. So in question 1, the scenario was that 10 metaphases showed just an additional X chromosome, and the remaining 10 metaphases showed an additional X chromosome as well as an isochromosome for the long arm of chromosome 8 and the 2 normal chromosome 8s. And we told the participants that it was not known whether the additional X chromosome was acquired or constitutional. So this was the karyotype ideogram provided. And this was the recommended answer. So to get to this answer, you need to be aware of that the nomenclature defaults to a likely constitutional origin until proven otherwise. So if the additional X chromosome is constitutional, then it would be listed as 47 XXX. If the additional X chromosome was known to be acquired, then it would be 47XX plus X. So because the nomenclature defaults to a likely constitutional origin, 47XX query C is the preferred option. And this should come at the end of the answer, because if it's constitutional, it cannot be at the beginning as a basic stem line, because a stem line can't be a constitutional karyotype. Then looking at the chromosome 8 abnormality, there are two equally acceptable ways of writing this. So you could say that there are two normal 8s and the additional isochromosome 8, the abnormal one is the additional one, so you put the plus iso 8. Or you say that the isochromosome 8 replaces one of the normal 8s and the second chromosome 8 is the additional one. So there are various correct answers in this question. You could also use the stem line designation or IDEM. But as I've said, you cannot have the 47 XXX query C first. There were some participants who gave two options, either writing the option of the additional X was constitutional or that it was acquired. So there were two options and they were accepted. But this option with 47XX plus C was not allowed, was allowed but wasn't penalised. So then moving on to question 4, which was also quite challenging. And the fundamental principles looked at here were the placement of the query C when to show constitutional origin when there is both a constitutional and an acquired trisomy 21. Identifying which abnormalities are clonal in a composite karyotype, so which should be included, and working out the correct range for the chromosome count. So these were the results provided for this EQA question. There were 10 metaphases showing just an additional chromosome 21, and the remaining 10 metaphases showed multiple numerical and structural abnormalities, and we gave participants a table showing each abnormality in each metaphase. So in order to work out the ISCN for this composite karyotype, you first need to work out which cells carry clonal abnormalities to work out the chromosome count. So in this scenario, every metaphase had at least one clonal abnormality. So you work out your chromosome count range from using the counts of all of the metaphases in this case. Then you work out which abnormalities are clonal. So everything in green here is clonal. One's not highlighted, so an extra chromosome 4 was just seen in one cell, so that is not clonal. Similarly for chromosome 5, there was one cell showing loss and one cell showing gain, so that was not clonal. So the interesting part here was that there were two cells that were showing loss of chromosome 7, and those two cells also had the same numerical and structural abnormalities. So the loss of chromosome 7 in this scenario can be regarded as a clonal abnormality, even though it was only present in two cells, which is the normal rule. So two cells with identical losses of one or more chromosomes and the same chromosome gain or structural aberrations may be considered clonal and included in the same nomenclature. In real life, professional judgment is required in clinical situations, and you might want to gather further evidence prior to the inclusion of the monosomies, such as monosomy 7 in this case, prior to including that in the karyotype. But for the purposes of the EQA, we weren't assessing any interpretation, we were just looking at the application of the EQA rules, and therefore the monosomy 7 should be included in the karyotype. So this is one of the possible ISCN nomenclatures, listing the clonal abnormalities as a composite karyotype in 10 cells, And then again, there's no normal cell line, but the constitutional trisomy 21 cell line is effectively the normal cell line in this case, and so that comes at the end. Another way of writing it is to put the number of cells with the clonal abnormality in square brackets after each clonal abnormality. Looking at the order of the abnormalities in the description, where we have an additional constitutional trisomy 21 and an acquired trisomy 21. The constitutional trisomy 21 should be listed first. Rings should be described before marker chromosomes, and double minutes come after the marker chromosomes and should not be included in the chromosome count. So 2% of participants answered all these 4 questions correctly. So it was question 4 that was particularly challenging, as we've seen, and 15% of participants got this question correct, whereas questions 1, 2, and 3 were generally answered well. And a recurring error in this case was putting things in the wrong order. So either cell lines in the wrong order or the aberrations in the wrong order numerically or alphabetically. So in these EQA questions, we didn't focus on any particular ISCN 2020 updates, but we saw that many participants are still struggling with these basic concepts, such as the order of the aberrations. Moving on to oncology FISH, there were several fundamental principles that needed to be applied to correctly answer these questions. So the numerator denotes the number of abnormal cells and the denominator the total number of cells analysed. However, in a somatic chimera result, you only need to provide the numerator. We had a question that had a G-banding information and metaphase FISH information. And so if you're providing a full set of results with a G-banding result and a FISH result, you don't have to repeat the translocation breakpoints for the FISH result. But if you're only giving the FISH result, you need to include the translocation breakpoints. Again, there were issues with the order, so the abnormal probe sets should be listed in numerical chromosome order. And similarly to the constitutional ISCN, there's an update in 2020 as a clarification that normal control probes should not be included in the ISCN unless clinically significant. And also we looked at the transcript orientation of genes, and this should be respected. So we'll look at this in a bit more detail. So question 4 provided multiple FISH probes with different results. And picking out these 2 FISH probes, we can see that the BCL6 probe runs, the gene runs from 3' to 5', whereas the MIC probe is the opposite orientation. So this should be considered when writing out the ISCN. So the scenario was that there was an abnormal signal pattern with a BCL6 break apart probe. There was loss of MIB. There was a standard MIC rearrangement, and there was a BCL2 IGH fusion with a variant abnormal signal pattern. So the different probes should be listed in the numerical chromosome order. So BCL6 being on chromosome 3 comes first, then MIB on chromosome 6, MIC on chromosome 8, and BCL2 at the end because that's on chromosome 18. And each probe set, we said that there were 95 out of 100 cells were abnormal for each probe set. But even though the results are the same number of cells abnormal, the cell numbers should be given after each probe set tested. And looking at the nomenclature, you can see that the BCL6, the 3' part should come first and then the 5' part, whereas with MIC, where there's a MIC rearrangement and the 5' separated from the 3', they should be listed that way around. So 26% of participants answered all 4 questions correctly in this case. The common errors for question 1 were where participants gave more than one contig, they should be separated by a backslash in the ISCN, and there were some errors where a comma was used instead. Question 2 was the somatic chimera result. So it was a bone marrow transplant with female donor and host male cells, and this was answered very well. Question 3 was the one where G-banding information was given as well as FISH information. And although it was a straightforward CBFB rearrangement, there were 37% of participants who received deductions because they omitted to include the translocation breakpoints and they gave only the FISH ISCN. And a recurring error throughout this question was putting the FISH probes in the incorrect order. So there were no recent changes to the ISCN principles assessed in the EQA questions, but I'd just like to point out that a new section has been added for 2020 on tricolor probes, and you should have seen that. We're going to be looking at that in one of our quiz questions later. And again, we saw that some participants were still struggling with the basic concepts, such as the order of the probe sets, given the cell numbers after each individual probe set, and again, correctly describing the orientation of break-apart probes. So the fifth case that was provided was covering microarray ISCN. Again, there were 4 questions for this case. The first question was an aneuploid case, and some of the errors were including the genome build, which is not required for aneuploidy results. Questions 2 and 4 gave inheritance information, and again, it's optional to include this, but it should be used consistently. Question 3 was an acquired array result, but there was also a constitutional aberration, and the origin of this must be given by using the C designation to make it clear that that is not part of the acquired abnormalities. And an update in ISCN 2020 is that you're now able to use commas in the nucleotide coordinates if you choose to. So 3% of participants answered all these 4 questions correctly, and the aneuploidy question was answered very well. Questions 2 and question 4 with the inheritance information, we saw that some participants put one part of the inheritance information, but not the other, even though it was given in the question. So where there was inconsistency, the ISCN was not clear, and if inheritance information is not given, it could be misinterpreted as that inheritance information is unknown. So although inheritance information is optional, it should be given consistently throughout the ISCN stream. Again, as I mentioned before, question 3 was an acquired array result, and many participants omitted to include the origin of the constitutional trisomy 21. And as I said before, with the FISH ISCN, we particularly saw quite a lot of punctuation errors with the microarray ISCN as well. So one of the big updates for microarray ISCN in 2020 is that the aberrations of the sex chromosomes are now listed first, regardless of whether there's a copy number gain or not. And as I mentioned, you can include commas, but again, consistency is essential. And moving on to region-specific assays. So this area of ISCN covers multiple techniques. To make all of the different cytogenomic and molecular techniques consistent, again, as with microarrays, the sex chromosome nomenclature should now be listed first. And as usual, the abnormal results are listed in numerical chromosome order. There was further examples and clarification for ISCN for mosaic QF-PCR results, which we'll look at in a minute. And with this RSA nomenclature, there are often several versions of the ISCN that can be used, and some options are more informative than others. So perhaps if you feel that a simpler version of the ISCN, although not informative, is what you're going to choose to use, that would be acceptable, but any information which is omitted should be stated in the report. So for example, if you're just going to give an MLPA kit name for simplicity, the informative markers or genes should be given in the text description of the report. So 52% of participants answered all 4 questions correctly. So this case was handled very well. All questions were answered well. And in this case, the majority of participants were aware of the update for listing sex chromosomes first. There were a couple of errors in question 3 where the location of the probes were omitted, and these should be included in MLPA results. And again, there were some punctuation errors. So just to highlight again, for ISCN 2020, sex chromosomes should be listed first. And for a mixed cell population, you can include, if you know it, the most informative way of writing the ISCN is to include the proportion of the abnormal cells in square brackets, such as here. So the 0.5 is showing that 50% of the cells have trisomy for chromosome 18. If you can't give an exact proportion or estimate a proportion, then you can just give the copy number range. So that would be 2 and then the tilde sign and then 3 to show that there are 2 or 3 copies. But obviously the 50% is the more informative option. And across the EQA, there were several other errors, such as ordering results where multiple techniques are reported. Some participants perhaps didn't read the question properly and used metaphase fish ISCN for interphase results, or the other way around. There were some typographical errors. So obviously the breakpoints, you didn't need to analyze the case. The breakpoints were given, and yet sometimes this was listed incorrectly in the answers, or the probe names were incorrect. And perhaps some of the time, perhaps the question was just not read properly. So those were the results from the ISCN pilot EQA, which was run in 2021. It will be run in a similar format in 2022. So the 2022 EQA will open in October. This time, instead of 5 weeks to submit the results, we'll give you 6 weeks. And the results will be submitted in the same way, and again assessed by a panel of ISCN experts. This is still a pilot EQA, and it's slightly different to our other EQAs, so there is no performance monitoring. And there's further information on our website if you wish to enrol. So for anybody who's not familiar with our website, this is the homepage of the website, and you need to, prior to enrolling in an EQA, you need to be a GenQA member. So this is the page where you join GenQA. And then this is screenshots of the ISCN 2021 EQA, just to show you, again, it will look similar in 2022. So for example, you'll be given a chromosome ideogram and a text description of the result. There'll be a form to complete where you basically just say whether you want to participate or not. So if you don't want to participate, you just click no and submit. And if you do want to participate, then you have a look at the different questions and you enter your ISCN nomenclature directly into the boxes on the form, and you press submit to complete your submission. GenQA are also working with our software providers to develop bespoke software. So the EQAs that I've just been talking about are laboratory-based EQAs, but we hope to offer modules for individual competency assessment as part of our genomics training assessment and competency tool. So we call this the GTACT module. So these will allow personalised participation according to any particular staff member's knowledge and experience. And we hope to provide different options. So we'll look at different sample types and techniques and perhaps different levels of complexity. And we hope that this will be useful for training as well as assessing individual competence. And the website will provide instant feedback on the results. So this is the page that lists our current GTACT module. So when the ISCN module is available, you'll be able to find it on this page, along with our other rolling laboratory modules such as sample reception and variant interpretation. Other educational activities provided by GenQA, we are now launching some workshops. So our first workshops will be held in September in Rome, and these are only open to our EQA participants, and we'll work through the principles right from the beginning so you can increase your knowledge and understanding and prepare for the 2022 ISCN EQA. And we welcome you bringing along your own challenging cases to discuss and work through together. We hope to offer more workshops in the future, so we're looking at London in 2023, and please get in touch using our email address if you would like a workshop local to you. We'll see what we can arrange. Okay, so now we're moving on to the quiz section of the webinar. So you should have received 4 questions in the webinar registration email. And what you can do is, if you've considered your answers, you can vote in the poll that's going to come up shortly. And we can see what the spread of results are. Don't worry, because the responses will be completely anonymous. And also I'll show the questions again to anybody who didn't see them on the email. So this is the first question. So we're looking at which ISCN options are correct for an unbalanced Robertsonian translocation between chromosomes 14 and 21, which is maternally inherited. So I'll just give you a minute to read through those options. And then what we'll do is we'll launch the poll and you'll be able to select A, B, C, D, or E, or more than one if you choose. And then we'll close the poll and you can have a look at the results. So just give you a little bit longer to look at that. Okay, so let's launch the poll now and please vote. Okay, so sorry, it's a bit small on my screen, but we can see that the majority of participants have gone for option C. Nobody thought option E was correct, and the second most popular option was D. So let's look at the answers. Okay, so D was the correct answer. So we'll work through each example. So A was incorrect because the abnormalities are listed in the incorrect order. So chromosome 21 should come after the aberration with chromosome 14. B is incorrect because it has an incorrect chromosome count. So in a whole arm translocation, such as a Robertsonian translocation, you only count that as 1 chromosome. So there should be 46 chromosomes for an unbalanced karyotype. C is incorrect because it's using the DMAT designation and not the MAT designation. So the Robertsonian translocation is inherited in the same way as in the mother. There's no difference to it, but with this patient, they have also inherited an additional chromosome 21. D is the correct answer. So you can use a DER designation as well as a ROB. E is correct, multiple ways. It's got the wrong chromosome count. It's got the inheritance information at the end when it should be after the abnormality that it refers to. So there was also an alternative correct answer, which wasn't listed on the poll, which is obviously the same as D, but using the ROB designation instead of the DER for derivative. Okay, so question 2 was covering constitutional fish ISCN. So this was looking at a prenatal result of uncultured cells, so interface fish, and 15 out of the 50 cells examined showed a signal pattern consistent with monosomy X, and the others showed a normal female result, so 2 chromosome X centromeres and no signals for SRY. So I'll leave you a few minutes just to reread that question, think about which the correct ISCN is. And we'll look at the correct answer for this one. So the majority of people who voted have gone for option A, followed closely by D. Again, nobody's voted for E. So let's hope that option A is correct in this question. Let's look at the answers. So yes, so most people who voted were correct. Option A is correct in this scenario. So we've got the, let's work through the wrong answers. So B is incorrect because it's not giving the total number of cells in the denominator. C is incorrect because it's not including the SRY in this sex determination result. D is incorrect. This can see this could be confusing. So the difference between A and D is that the cell lines are the other way around. So in D, the majority cell line is listed first. However, this also corresponds to the normal female cell line. So that's why A is correct and not D. The normal female cell line with 35 cells with 2 X centromeres should come at the end. And E is incorrect, an incorrect use of brackets. And also, again, the cell lines were the wrong way around. Okay, so question 3, I appreciate not all of you will be using triple colour FISH probes or doing acquired abnormalities, but please feel free to vote, have a guess. So this question is looking at a complex FISH probe. So it's 3 colours covering 3 different genes on chromosome 4. So the FIP1L1, the PDFRA gene, and the CHIK2 gene, which comes in the middle. So in this result, there were 63 out of the 100 cells which had a deletion of the CHIK2 gene, and that brought together the FIP1L1 and PDFR genes in a fusion. And then the remaining 37 cells showed the 2 normal triple fusion signals, so the normal signal pattern. So we've got 4 options to choose from for this question. I'll let you read through them briefly. Okay, so less of a spread on this one. So B is the most popular answer. So let's have a look and see if B is correct. And yes, so B is correct. So well done, those people who voted for B. A is incorrect, so it's not giving the total number of cells examined, and it's also listing the normal cell population, those 37 cells which are normal, so those don't need to be listed in the ISCN. The difference between the options for B and C are the use of CON for connected and SEP for separated. But in this scenario, so the FIP1L1 and the PDFRA have brought together and fused. So CON is the correct designation to use. And D is incorrect because this is interface FISH. You shouldn't be using the plus and the minus. Okay, and then the last question is covering microarrays. So hopefully this is a bit more simple and quicker to read as well. So we've got an array result which is consistent with an XYY sex chromosome constitution. So there's only one correct ISCN listed here out of options A, B, C, and D. I'll give you a few seconds to look at that. Okay, so vast majority of people who voted have gone for option B. So hopefully this was a more straightforward question. Let's check to see if option B is indeed correct. And it is. So the sex chromosomes should be listed in the order X and Y, even though it's the Y that's abnormal here. Option C misses out the X completely, and option D, although the ISCN for the X and Y is correct, you don't need to include the genome build for this aneuploidy result. So I hope you found that quiz useful. It'd be nice to have some feedback on doing the quizzes in the webinars. I think hopefully you found it useful to have the questions beforehand so that you can read them in your own time and consider the correct answers. So that concludes our webinar presentation for today. I'd like to thank you all for your attention. If you need to contact us, and there's myself and Roz's details there and our email address. And as Roz mentioned, we do have, if you have any particular ISCN questions, there now is an online forum on the CARGA website where the experts can answer your particular ISCN questions. But anything obviously related to EQA or GTACT or our workshops, please email us at info@genqa.org. So we'll now move on to our question and answer session, which Roz is helping us with today. So I'm just going to have a look on the questions box, and I can see that Roz has been answering some questions individually on there.
Yes, I thought it was easier to do so because
yeah.
it would be difficult for people to see them. But there's one that I will answer straight away, and I think it's gone to everybody, but I'm not sure. And that was why in the examples we've given, we've not put MOS or Mosaic. MOS is the abbreviation at the beginning of the ISCN string. And if you go right back to section 4.1 where there's bullet points, you will see that it's an option because the verb is may, and may implies optional. So it is optional, and there are examples in the book where the Mosaicism has got MOS in front of it and where it hasn't. So we put lots of examples in the book, hopefully, to show that you can or can't, where it has to be done, we do it. There's a couple of other questions. There's one, if I can find it. Oh gosh, I can't find it now.
And
there's
just
one about the translocation.
Yeah, I was just going to say, if we are unable to answer your question online, we will have your details so we can respond individually to any questions that we don't manage to answer online. Have you found that question, Roz?
I've got another question here regarding question number 3. Do we always have to write the probe type LSP in the ISCN result? If you go back to section 13.2, you will find out what designations that you can do. It's in that section. It tells you what you can do. It's at the discretion of the investigator, laboratory director, whether you give the probe name, clone name, accession number, gene name, or D number. And the reason we often say the clone is simply because it tells you exactly what you're dealing with. If you use the probe name, sometimes, although it might say TP53, I'm just using a hematology example, it actually doesn't cover the TP53 gene, it's just outside it. So you do need to know where your probes are. All right, let me see what else. Does that answer that question?
Yes, I think so. There's one EQA related, so I can answer that one. So somebody's saying that if you're actually going to participate in all the 6 questions, obviously with 4 questions in each, that's quite a lot of work to do in the time available. And so have you got any plans for changing the delivery of the EQA? And so, as I said, we will be running the 2020 EQA in the same format. You can obviously opt out, but yes, you will have to answer all of the questions within the 6 weeks available now. So we have recognised there is a lot of work to do, so there is an extra week this year. But what we're looking at doing in the future is splitting the EQA into 2 separate rounds. So what we'll probably do is have the constitutional karyotyping and FISH and the acquired karyotyping and FISH in one round. And then anything else, so microarray, RSA nomenclature, we'll try and put sequence nomenclature in the future as well. So that will be a separate round that will come later in the year, so the work won't need to be done at once.
Got another question here. When the mother is a carrier of a balanced translocation between 3 different autosomes and the child has inherited only one of the derivative chromosomes, should we write, for example, DIR2T1 semicolon 2 or DIR2T1 semicolon 2 semicolon 3 ... DMAT? Obviously you put the DMAT in. You know the mother has a translocation between chromosomes 1, 2 and 3, so that is what they're inheriting, and you're inheriting the DIR2, so it is DIR2 of the T1, 2, 3.
Yes, I can see why that could be confusing. That
Yeah, but that's how you would do it.
Yeah. Okay, have we got any? Yep. Are there any other questions we haven't managed to answer yet? I think there's still a few coming through. Hang
on, there's one here. Even if we checked a double ring in 2 different cell lines, it would be considered an artifact. I think you're going to have to look at that on an individual basis, because it depends what you're looking at. They're usually unstable, and you need to know there's a ring there. It depends whether it's just a double ring on its own. If it's double ring on its own, that's a different kettle of fish to something where you've got a ring chromosome and you've got something that's happening in as a cultural artifact.
Yeah, if you've only got the double ring and no representation from a single ring, then having a double ring in multiple cells would suggest that that double ring is stable.
Yeah.
But yeah, it would have to be done on a case-by-case basis. Okay, so if there are any questions that we haven't been able to answer, I'm just aware of the time. We will get back to you individually, and obviously we have our email address or the ISCN forum if you have any further questions.
And thank you for listening.
Yeah, so as I said before, we would welcome any feedback either in the questions box today, or you will be sent a survey through the webinar platform. Just a few short questions just to help us improve our webinars in future. The webinar will be available for exclusive access for those of you who have joined us live today. But after a month, it will be available to the general public on our YouTube channel. So anybody can access this. So colleagues, if you'd like to recommend watching our webinar, that will be there along with all the other webinars that GenQA have given over the past couple of years, which also includes some other webinars which are focused on ISCN. If you've joined us live today, you'll be sent a participation certificate link as well in the email. And in August, our next focus on topic will be lessons learned from the 2021 EQA for lung cancer liquid biopsy testing. So we hope that you can join us for that or recommend any colleagues who are specialising in that sort of testing. So that concludes the webinar. Thank you all for your attention. Thank you, Ros, for your input, and goodbye.